Today we get to explore the properties of the periodic table and figure out some of the things that make our periodic table so amazing. So for this lesson, you will want to have your periodic table out, and you can label it as I label the periodic table on this video. So before we go ahead and look at some of the characteristics of the periodic table, we do want to talk about two really important people. The first is Mendeleev and the second is Moseley. Mendeleev is credited with the periodic table and the first arrangement of it, so he's considered to be the father of the periodic table. He actually really loved cards, so what he did was he put all the properties of elements that were discovered at his time on cards, and he arranged them in an order that kind of made sense to him. And he figured out that he's going to arrange the elements by increasing atomic mass. He allowed gaps in his cards, which later actually were elements that were discovered after his periodic table were put together. So after Mendeleev came Moseley, and he organized the elements by increasing atomic number. So today we do use increasing atomic number to organize our periodic table. And he found that elements with similar properties fall into the same column or group. So another word for that is families. He was able to explain some of the difficulties that Mendeleev had with his periodic table. An example was that iodine has a greater atomic number. However, it had an atomic mass that was less than tellurium. So it didn't really make sense in the arrangement of Mendeleev's periodic table. So these two guys are really important. And today we organize our periodic table by atomic number. And Mendeleev, although he was the first to arrange it by atomic mass, we just found that the atomic number makes a little bit more sense. So let's go ahead and look at our periodic table. So the very first thing I want to go ahead and bring to your attention is this staircase right here. Okay, this staircase kind of breaks apart our periodic table. Elements that are to the left of it are metals, and then elements that are to the right of it are called nonmetals. And then the elements along the staircase are called metalloids or semimetals. So I'll write that for you guys down here. And our metals take up majority of the elements on the periodic table. Metals are hard and shiny. They conduct heat and electricity. Two really important characteristics of metals are also that they are malleable and ductile. Malleable means that you can hammer them into sheets like aluminum, and then ductile means you can draw them into wire, such as copper wiring. And most metals will lose electrons to become cations, so they form that positive charge in order to fulfill the octet rule. And they usually only have 1, 2, or 3 valence electrons. So if we're looking at our periodic table, one thing you will want to notice is that although hydrogen is to the left of the staircase, it is not a metal. So this is our exception. So we'll talk about hydrogen a little bit later on. So that's a major characteristic of our periodic table. Also, if you look, your periodic table is already numbered. So we have 1A, we have 2A, and then we have 3A, 4A, and so on, and then 8A. So that's one way to number it. And then we also have just 1 to 18, if you notice. So those going down, those are called groups or families. Okay, so and they're called families because elements that fall into the same group have similar characteristics. The difference between the A and the B's are that the 1A, the 2A, the 3A, and so on, we call those our main group elements or representative elements. And then the elements that fall into the 3B to right here, we don't really use that numbering too much, but those we'll talk about later. Those are our transition metals. So groups are going down, and then going across, we call those periods or rows. Okay, so there's 7 periods on the periodic table, so it's numbered 1 to 7 down here. And then these guys down here, we'll talk about this group as well. But this, the lanthanide series actually belongs in period 6, and then the actinides down here belong in period 7. One of the reasons that we have them below the periodic table is that it wouldn't really fit on a nice poster size paper if we actually had them inside the periodic table, because it would be too long. So we kind of simplify it and have those two groups at the bottom. And then if we look at our nonmetals that are to the right of the staircase, some characteristics of nonmetals are that they're gases or brittle solids at room temperature. They're usually dull. They're poor conductors of heat and electricity, which makes them good insulators. And nonmetals usually become anions, which means that they gain electrons to become stable, and they usually have more valence electrons in their outer level, usually 6, 7, 5. So we'll go over that in a bit. And then along the staircase, I'm going to circle some elements for us, and these are called our metalloids again. So in that we have boron, we have silicon, germanium, arsenic, antimony, tellurium, and polonium. And metalloids, they have properties that kind of go with both metals and nonmetals. So an example would be silicon. Silicon is shiny like a metal, but it's brittle and it doesn't conduct electricity very well at all. So 3 main categories are metals, nonmetals, and metalloids. Now let's explore some of the families in detail. Okay, so in group 1, we have lithium, sodium, potassium, rubidium, cesium, and francium. These are called our alkali metals. Okay, and alkali metals are the most reactive metals of the periodic table. They are silvery and they're really soft. They can be cut straight through with a knife. And if you want to have some fun, you can go ahead and YouTube reactivity of alkali metals, and you'll see some really cool demonstrations. Later on this year, you guys will have the chance to do a lab where you use one of the alkali metals and you put it in water, and you'll see an explosion because they're very, very reactive. The group next to it, group 2, beryllium, magnesium, calcium, strontium, barium, and radium. Those are called our alkaline earth metals. Like your alkali metals, they are also very reactive, just a little bit less reactive than the alkali metals. And they're a little bit stronger and denser. They are also not found in nature as a free element. They usually combine with oxygen to form oxides. Calcium also will combine with carbonate. So calcium carbonate is found in marble. Okay, so our alkaline earth metals are also very reactive, just a little bit less reactive than that group 1 alkali metals. And then here, in this range right here, so we have groups 3 to 12. Those are called our transition metals. Okay, so transition metals are also metals, and their properties vary a lot from element to element. So we don't really talk a lot about them in detail. They're typically less reactive than alkali or alkaline earth metals. And examples of these that you guys have seen before, we have gold, we have silver. The one that I do want to bring to your attention is mercury over here. So mercury, although it's a metal, it is a liquid at room temperature. So that's one thing that you want to know, that mercury is a liquid at room temperature, and we'll look at another element that is as well. And I'm just going to go to your F block at the bottom right here. So we have our lanthanide series and our actinide series at the bottom. So we can label these. So lanthanide is, you can spell this if you'd like. Your periodic table might have it labeled as well, and then our actinides are at the bottom right here. And they also, we don't talk about them too much in detail either. They do have properties that kind of vary element to element. And again, you do want to know that the lanthanides do belong in period 6, and then the actinides do belong in period 7. So let's move along and let's look at some of the other elements and other groups that we have. So I do want to bring your attention to group 17 or 7A. We have fluorine, chlorine, bromine, iodine, and acetane. So these are called our halogens. So halogens are the most reactive nonmetals. Okay, so although they are all very reactive, we do have some different characteristics in this group. Fluorine and chlorine, they're gases at room temperature. And then as you go down, bromine is a liquid. So just like mercury is, bromine and mercury are both liquids at room temperature. So we can even write that right here so we remember. And then as you go down, iodine is actually a purple solid. So we have solids, liquids, and gases in our halogen group, which is very unique. And then if we look at our last group, right here we have helium, we have neon, argon, krypton, xenon, and radon. You guys probably know those are called our noble gases. So our noble gases are the most stable elements on the periodic table. Everyone but helium has 8 valence electrons that make it really stable. They fulfill the octet rule. Helium is also stable, but it has 2 electrons in its outer shell. Now that we've looked at our main group elements, as well as our metalloids and transition metals, let's go take a look at some of the elements that we have not discussed. So if we go back to our normal periodic table here, I'm going to go ahead and circle elements that fall into a category called SNOPs. So CHNOPS. So in that category, we have carbon, we have hydrogen, we have nitrogen, oxygen, phosphorus, and sulfur. And then sometimes we also include selenium into that category, so we can call it SNOPC. So these are our nonmetals that don't fall into other categories, and all of these nonmetals are essential to life. So nitrogen, carbon, hydrogen, we need all of these things to survive. So we call those our other nonmetals, or the SNOPs category. And then also there's some metals that we didn't talk about. So we have aluminum, gallium, indium, tin, thallium, lead, and bismuth. So those are, we can classify those as other metals. Okay, so these metals are, they're metals just like our transition metals, but they usually don't conduct electricity as well as the metals that we've already discussed. And then we've talked about this before, but valence electrons is something we also want to look at. So in group 1, we have all of these elements have 1 valence electron. Group 2, they have 2 valence electrons. We talked about the D and F block, and we said that usually they all have 2 valence electrons. And again, there are some exceptions to the rule, but for right now, we're just going to say that they all have 2 valence electrons. And then we go to group 3A or 13. 3 valence electrons, 4, 5, 6, 7, and then all of our noble gases have 8 valence electrons except helium. Remember, it has 2. So this is something we've talked about, and later on we're going to figure out why things bond and if they form an ionic bond or a covalent bond. And because of that, we want to look at something that we call the common net ionic charge for all the elements. So I'm going to label that, and we'll talk a lot more about that later on, but it is something we want to start to explore. So all of our group 1 metals, they form a +1 charge. Okay, so that means they will become cations and they will lose 1 electron in order to become stable. And then our group 2, they will become +2. And then if we go ahead and we skip to our boron family over here, those elements become a +3. So notice that metals become cations and the nonmetals become anions. And then if we look at our carbon group, we're going to say those can actually form a plus or -4. So usually you'll see that they're involved in covalent bonds and they're sharing their electrons. And that's why we're going to say plus or minus 4, but usually they're going to be sharing. And then let's just start with let's go backwards and start with our noble gases. So our noble gases, they'll have a common net charge of 0 because they're already stable. They don't need to lose or gain electrons. So they are not really involved in any type of bonding. And then our halogen group, they become a -1. So that means they only need to gain one more electron to become stable. And then our oxygen group will become a -2. And then our nitrogen will become a -3. So we call those common net ionic charges, which is something we do want to start to explore. So now that we've talked a lot about the periodic table and you've learned what periods and groups are and you've learned the different family names and some of the characteristics of the elements, we have some homework questions for you. So go ahead, make sure you write down the question and you answer the question completely. If you're unsure of how to do it, fill out a sentence frame, come to class with any questions that you may have. Thanks. Enjoy the rest of your day.